So today we will discuss about one important problem on Gauss Divergence Theorem. To verify Gauss Divergence Theorem for f bar equal to 4xzi minus y square j plus yzk. So over the cube bounded by x equal to 0, x equal to 1, y equal to 0, y equal to 1, z equal to 0 and z equal to 1. Now, so given, so what is given? F bar equal to what? 4xz I minus y square j plus yz k. Okay, coming to the boundaries, so x is from 0 to 1 again, so y is from 0 to 1, so z is also from 0 to 1. Now, so by Gauss Divergence Theorem, so we have a relation between surface integral and volume integral. So that is, so double integral over the surface S f bar dot n cap into ds equal to, so triple integral over the volume V, so divergence of f bar into dv. Now first of all, so we need to evaluate triple integral over the volume. So coming to the RHS, so it is triple integral over the volume, so divergence of f bar into dv. Now coming to the divergence of f bar, so what is the divergence of f bar? So it is gradient into f bar. So gradient dot f bar here. So what is gradient? So I dou by dou x plus j dou by dou y plus k dou by dou z. So dot. Now coming to the f bar, so what is f bar? 4xz I minus y square j plus yz k. Now see, coming to the dot product, so now I into I dot I is I square, so dou by dou x of 4xz. So if you want to differentiate with respect to x, treat z as a constant, 4 already constant, 4 z is a constant. For x the differentiation is 1. Next, so j dot j is 1. Now dou by dou y of y square is 2y, so minus 2y. And finally k dot k is 1, so dou by dou z of yz. So if you want to differentiate with respect to z, so treat y as a constant, so plus y into 1, so 4z minus 2y plus y is what? Minus y. So now divergence of f is ready, 4z minus f bar is ready, 4z minus y. Now if you want to integrate with respect to triple integral, for z it is from 0 to 1, for y it is from 0 to 1, for x also it is from 0 to 1. Divergence of f is what? 4z minus y. So now first integral having the z boundary, so that we need to integrate with respect to z first and then y and then x. Okay, now coming to the integration, so double integral over the boundaries 0 to 1 and 0 to 1. Now so we need to integrate with respect to z, so that for 4 is a constant, for z it is z square by 2 minus y is a constant here, z for 1 it is z, so 0 to 1, so dy to dx. So now 2 1s are 2 2s are gets cancelled, so from 0 to 1 and from 0 to 1, so 2z square, so 2 into 1 minus, so in place of z we have 1, so it is y. We need to substitute lower boundary which is 0, so dy dx. Now coming to the integration with respect to y, so from 0 to 1, so with respect to y 2 is a constant, for 2 it is 2y minus y square by 2, and the boundaries are 0 to 1 dx. Now substitute the upper boundary, so which gives, so integration of 0 to 1, so 2 into 1 minus 1 by 2 to dx. We need to substitute the lower boundary. Now 2 minus 1 by 2 is what? 3 by 2, so 3 by 2 is a constant, put it outside, and the boundaries are from 0 to 1, so what we have? 1 dx. Now for 1, with respect to x it is x, and the boundaries are from 0 to 1. So simply, so write h value is 3 by 2. Now coming to the LHS, which is so double integral over the surface S. So clearly, which is double integral over the surface S f bar dot n cap ds into ds. Now coming to the cube, so he has given over the cube and having the boundaries 0 to 1, 0 to 1 and 0 to 1. So that coming to the boundaries, by using the boundaries we will construct a figure like this. So x, y, z. So clearly so this is the cube. Okay, now take the values. Origin, okay, on the x-axis it is b. Now a, b, c, d, e, f, and then g. Take the values whatever you want. Okay, now so it is x equal to 1, so which represents, so this line represents x equal to 1, and this line represents so y equal to 1. So and this is what, z equal to 1. So clearly it is on the x-axis, so which is nothing but, so it is an I vector, it is an j vector, and it is a k vector. So please observe this cube. So we have 6 faces. So front face, back face, so which is so front face is what, OBGF. OBGF is the front face. Then coming to the back face, OCDE. So back face, so OCDE, that is the back face. Now so front and back is over. Now coming to the left, right. So coming to the left face, OAFE is the left face. Now coming to the right face, so CBGD. So CBGD is the right face. Now so left, right, over. Now coming to the so up and down. So the upper face is what, EFGD is the upper face surface, and coming to the lower surface, OABC. So these are the 6 faces we have. So we need, if you want to integrate, double integrate over the surface S, so we need to integrate by using all these 6 surfaces, so that we can write, so this one as, terminate as, so double integral over the surface S1, so f bar dot n cap ds, so plus double integral over the surface S2, f bar dot n cap ds, so that is S3, so f bar dot n cap ds, plus S4, f bar dot n cap ds, plus S5, f bar dot n cap ds, and finally the 6th face, S6, f bar dot n cap ds. So we need to evaluate all these 6 faces. Clearly, so I can take the surfaces. So by using this box, you can easily find. I can draw a box like this. So coming to the first one is surface. So we have 6 surfaces, okay, and the main thing is here, so what is our f bar? So clearly 4xz I minus y square j plus yzk. Okay, now coming to the first surface. So surface is what? So front surface. So front surface is clearly ABGF. So this is the front surface ABGF. Okay, which is nothing but S1. So ABGF. Okay, so now write down all the 6 surfaces. Now coming to the second surface, front and back. So the coming to the back surface, OCDE. So S2. So S2 is what? OCDE. Now so front back over. Coming to the right surface, so BCDG. So BCDG. So that is the right surface. So S3. BCDG. Okay, now coming to the left one. So left is what? OAFE. Okay, so OAFE. All right, OAFE. Now fifth one, and finally sixth one. So fifth is what? So lower surface OABC. So this is the lower surface, and the sixth one is upper one. So OABC, that is the fifth one. Coming to the sixth one, upper one. So EFGD. So EFGD. So EFGD. Okay, students. Now surface is over. Now coming to the equation for this surface. So that is the second thing. So coming to the equation. So first surface ABGE. So ABGE. So front surface. So is at a distance of. So this one is x equal to 1 clearly. So this is the distance of y equal to 1, and this is the distance of z equal to 1. So these are the equations. So the front surface is at a distance of 1 unit from x-axis. So along the x-axis. So that the equation is x equal to 1. Now the back surface OCDE lies on the xz plane like this, so that no value for x, since it is x equal to 0. Okay, now coming to the BCDG. So BCDG here, so it is y equal to 1. So it is clearly, it is at this surface, it is at a distance of y equal to 1 from origin. So it is y equal to 1. So OAFE is like lies on the origin, so that it is, since it is y equal to 0. Now OABC. So OABC is what? So lies on the origin, so that clearly z equal to 0. So why? Because lies on the origin, so no distance from any other. So coming to the upper surface, it is at a distance of 1 unit along the x-axis, so along the z-axis. So z equal to 1, since it is z equal to 1. Now coming to the n cap. Okay, students. So this is very important, n cap. So for the first surface ABGE. So ABGE. So this is a positive direction from the direction through x-axis. So this is in the positive direction. So front face, it has a positive direction, so that the direction is positive, so that we need to take plus I. So this has a positive direction. Now coming to the back surface. So if it is a positive direction, back surface is clearly negative direction. So it is the front surface. Now coming to the back surface. So ABGF coming to the back surface. So it should be like this. So here it is. So it has a negative direction. So since it is minus I. Okay students, then y equal to 1. So coming to the y equal to 1, so which means B, C, D, G, this surface, so this one has a positive direction since it is J, which means it is a negative direction. Why? Because so this surface is so a negative direction from y equal to 1. Okay, next OABC. So OABC so lies on the so this plane, so that it has a negative direction since the value is minus k. So why? Because it is a positive direction, so upper surface is in the positive direction, so it is plus k. Okay students, then the next very important thing is f bar dot n cap. So that f bar dot n cap we need to find. Okay, see students, so f bar dot n cap is what? I. So I bar dot I bar is what? 1. So I bar dot j bar 0, no need to take this. I bar dot k bar is 0, no need to take this. So since it is 4xz, so minus I bar dot 4xz I, it is minus 4xz. For j it is 0. Now coming to the dot product of j, so j bar dot j bar is 1, so other 2 is 0, so that it is minus y square. So minus j bar since it is plus y square. Now coming to the minus k square, so minus k bar dot k bar, it is 1, so that it is minus yz. So k bar dot k bar, simply it is yz. Okay students, now the very important one is at that point. So why? Because the surface at this point x equal to 1, and here this surface at this point x equal to 0. So clearly, so at the point f bar dot n cap is what? So this is the very important one. So at this point, so what is that behavior? So clearly here x is what? 1. Now see these two, now substitute x equal to 1, this what we get? 4z. 4 x is what? 1 and z, so that it is 4z. Now substitute x equal to 0 here, it is 0. So y equal to 1, it is minus 1. So y equal to 0, substitute here, if you get 0. So z equal to 0, we will get 0. So z equal to 1, we will get y. So these are the values. Now finally the very important thing is what? ds. How to find ds? Now coming to the surface again, so ABGF, so this is the last one, ABGF, so that is the front face, ABGF. Okay, see, since so clearly, so what we observe, the directions of ABGF, you observe this clearly. So AB through along y axis, BG along z axis, so that so this is what? dy, this is what? dz. So like way, so ds is what? The surface area, which is nothing but dy into dz. Why? Because so clearly what we observe, so AB is the direction along y axis, so along y axis, so dy and BG dz. So along at the same time, so coming to the back surface, it is also same along y axis and along z axis, since it is dy and dz. Now coming to the right surface, so coming to the direction of right surface, since it is, so it is the direction of x axis and it is the direction of z axis, so it is very clear that it is dx into dz. It is also same dx into dz. So finally upper, so it is along x axis, so it is the direction along x axis and this is the direction along y axis, so dx into dy. So this is the also same dx into dy. So this is the very important box and very easiest. Okay students, now coming to the solvation, see, coming to the 6 phases, S1. For S1, f bar dot n bar at this point is what? 4z, and ds is what? dy dz. so that write clearly first one. So double integral, so under the surface wherever it is we have the boundaries like 0 1 0 1. So f bar dot n cap for s1 is what 4z into dy dz. So 4z into so dy dz. So plus. Now coming to the second surface s2 which is 0, so no need to take any value, plus third surface which gives a negative result, so minus, coming to the double integral 0 1 0 1. So for the third surface ds is what, and 1, so minus 1, or else you can take like this, minus 1 dx dz. Now coming to the fourth surface it is simply 0, plus coming to the fifth surface simply it is 0. Now coming to the sixth surface it is y. So double integral of 0 to 1, so 0 to 1 y dx into dy. Okay students, now we will solve this. So clearly, so here we have a z value, so that, so 0 to 1, so 0 to 1, so 4z times of dz into dy. So then we need to integrate with respect to z first and then y. So it is very, very simple. Next, minus double integral of 0 to 1, so 0 to 1, so dx dz, plus double integral of 0 to 1, 0 to 1, so y into dx into dy. Now okay students, now coming to the integration with respect to z, so 4 times of z for z, it is z square by 2, so boundaries of 0 to 1 dy, minus for 1 it is x, the boundaries are 0 to 1 dz. For y, if you want to integrate with respect to y, so we need to consider these two, so 0 to 1, so for y it is y square by 2, and the boundaries of 0 to 1, and finally we have dx. So 2 1s are 2 2s gets cancelled, so 0 to 1 2z square, simply it is 2 dy, minus if you substitute the upper boundary it is 1 dz, plus integration of 0 to 1, so 1 by 2 dx. Okay, so 2 is a constant, for 1 it is y, the boundaries are 0 to 1, for 1 it is z, the boundaries of 0 to 1, plus 1 by 2 times of, for 1 it is x, and the boundaries are 0 to 1, so 1 by 2 is a constant, put it outside, for 1 it is x. Now substitute the boundaries, 2 minus 1 plus 1 by 2, so 2 minus 1 is what, 1, 1 plus 1 by 2 is what, 3 by 2. So coming to the LHS, or it is 3 by 2. Coming to the RHS, so RHS it is 3 by 2, LHS it is 3 by 2, LHS equal to RHS, so hence Gauss Divergence Theorem is proved. So okay students, so thank you very much. So please do subscribe and share my YouTube channel. Thank you students.